Today, we're diving into a fascinating blueprint for survival, designed for one of the most complex places on Earth, the modern Japanese metropolis. This is all about how you build a digital fortress.
Just look at this. It's not just a city, it's a living ecosystem. You've got this incredibly dense web of transport, energy, data, and of course, millions of people all humming along together. Urban Japan is an absolute marvel of engineering. But that same density, that interdependence, well, that's also its greatest weakness. So the big question is, what happens when a massive shock hits this system? Something like a major earthquake. How do you stop one failure from triggering a dozen more? How do you protect millions of people when every single second is critical? That is the core challenge this whole framework is built to solve.
And here's the twist. The answer isn't just about stronger steel or deeper foundations anymore. The really crucial insight here is that modern resilience is built with code. It's all about transforming the city from just a collection of physical things into a single, smart organism that can actually think, react, and adapt on its own. So who are the people behind a project like this? Well, they're not your typical city planners. They're more like expert pilots or navigators for the city. It takes a whole specialized team, right? You need a chief navigator for strategy, a digital twin architect to build the virtual world, an operations orchestrator for automation, and a strategic auditor to make sure all the data is rock solid. Okay, so first things first. Before you can build anything this ambitious, you need a map. You need a master blueprint. This is all about charting the course and figuring out your destination before you even turn the key. The team started by zeroing in on what's known as a wicked problem. And trust me, this isn't just a hard problem. It's a tangled, knotted mess of conflicting interests and systems that just don't talk to each other. For a city like Tokyo, making it truly earthquake resilient is pretty much the ultimate wicked problem. To even begin to solve something like that, you need a totally new way of thinking. For decades, cities have been run in these fragmented silos, right? The transport department, the water department, the energy grid, they barely talk. The new way treats the entire city as a system of systems, where everything is connected and data just flows where it's needed. It's designed for a coordinated, resilient response from the ground up. This vision acts as the project's North Star. For this team, the goal was crystal clear: create an earthquake-resilient transit hub for Tokyo. Every single decision, every line of code is all pointed towards that one goal. And you measure your progress against clear, internationally recognized standards to know if you're actually getting there. All right, with our strategy locked in, now we get to the really cool stuff: building a living, digital mirror of the city. This is where we go from physical atoms to digital bits. Now, let's be super clear, we're not talking about just a pretty 3D map you can fly through. We are talking about true virtualization. Honestly, the best way to think about it is like a flight simulator for the entire city. It's a dynamic model that actually understands behavior, and it lets you test anything you want without any real-world consequences. So how do you make a digital model smart? Well, the secret sauce is a language called CityGML. It adds a layer of meaning, what we call semantics. So a simple 3D shape isn't just a shape anymore. The system understands, oh, that's a building, and it knows things about it, like its structural integrity or how many people are likely inside. It gives the raw data real context. But hold on, with all this data flying around, how can you possibly trust it? That is the job of the digital thread. It's this incredible concept that creates an unbreakable, completely auditable trail for every single piece of data. By using cryptographic linking, it basically chains the data together, proving where it came from and that nobody has messed with it. It creates total trust. And this is basically what that unbreakable chain looks like. Each link is cryptographically locked to the next. In the middle of a crisis, you can't afford to be second-guessing your info. This system ensures that when you're making a life-or-death decision, the data you're looking at is verifiable and absolutely trustworthy. So now you've got a smart model and data you can trust. This is where you get to play. You can run all these what-if simulations. What if we shut down this bridge during a quake? What if we reroute all the ambulances down this street? You can test policies, predict what will happen, and fine-tune your emergency plans until they're perfect, all safely inside the digital twin. Now we get to the really exciting part. How does this digital brain actually do things? This is all about creating automated reflexes for the city, basically an autopilot for when a crisis hits.
So the city's autopilot runs on what are called BPN workflows. I know, it's a mouthful, but you can just think of them as pre-programmed emergency playbooks. They're these incredibly powerful if this, then that recipes that can execute critical actions automatically, way faster and more accurately than any human team could ever hope to in a panic. Let's walk through it. Imagine seismic sensors detect a major tremor. Instantly, a workflow kicks in. The system automatically closes gas mains in the area to prevent fires. At the same time, it reroutes traffic lights to create green light corridors for ambulances. And for the really big decisions, it sends an alert right to the human navigator, putting them in the loop to make the final call. So how does the human navigator see all of this happening? They use a tool called the viewfinder. And this quote really gets to the heart of what it is. It's not just another screen filled with raw data and confusing charts. Its job is to give you clear, actionable intelligence.
Yep, the viewfinder is the navigator's cockpit. It is their single pane of glass, where they can see the entire city's health in real time. From here, they can monitor everything, run those what-if simulations we talked about, and step in to guide the system when it needs a human touch. It gives them total situational awareness. But this isn't a static, build it and you're done kind of thing. The real genius of this whole framework is that it's designed to learn and evolve. The journey, well, it never really ends. This happens through something they call a strategic patch. It's basically a software update, but for the city's entire operating system. So when the system finds a flaw, say a response plan didn't work as well as expected in a simulation, it doesn't just get written down in a report somewhere. The system's actual logic gets rewritten and patched to make it better for next time. And this is the ultimate payoff. By creating this constant feedback loop where the system detects a problem and then applies a patch to fix itself, you completely transform the city. It stops being just a collection of technologies. It becomes a resilient, adaptive, and self-correcting organism. Which leaves us with a pretty profound final thought. This whole system was designed for earthquake resilience in Japan. But if we can build cities that can truly learn from experience, that can adapt and actually heal themselves, just imagine what other wicked problems, from climate change to public health, we could finally start to solve.